Hello, this is Kendall Hiles with Mentor Graphics. I'm a member of the TSS technical sales team for high density advanced packaging. And I'm responsible for Xpedition Package Designer, Hyperlinks DRC, Hyperlinks PI, Hyperlinks Advanced Solvers, as well as Caliber integration for LVS checking and DRC checking using GDS output. So today we're going to be talking about the design of chip package board daisy chains with Mentor Xpedition Package Designer. So what we have is a test vehicle, and on the test vehicle we have daisy chains. So what is a test vehicle? It basically has the physical characteristics of your target design. So you have a product that you want to make, but you have some unproven or untested features in that, be it your bumps, balls, copper pillars, or some of the structures in the package or the silicon or the board. So the daisy chains are on the test vehicle. They're used to chain up pins to test these things, like mechanical connections. You know, the CTE, solderability, bump pawl pitch when you're doing you know, different pitches, and and your bump ball connections, your mechanical connections, or your copper pillars. You can also test physical structures like differences in materials or processes and design features, or copper structures like heaters, serpentines, offset vias in your package design. So you're pushing the manufacturing, seeing, can they do this? Can they do it reliably? So you're making a test vehicle that's easy to test. So you don't have to test something running with an operating system. You're testing it with the daisy chain and specifically testing for these features. Although this seems like a very, very simple concept, this can be difficult to visualize and track across your subsystem. You can have tens, hundreds, or thousands of daisy chains on your design, and it's just a daunting. So here I have a little demo. It's got my three RDL layers and my UBM layer. So I have my C4s. And what I have on here is multiple daisy chains, but let's just look at two. So if I look at this one right here, I go from a C4 up to a die pin. These blue connections represent the silicon connection. So this is actually on the die itself. Then we're going to jumper it on the package, die package, and then we're going to finalize it back on the BGA on the C4. Now this other structure over here, I've done the same thing, but in this one I want to test that I'm going to have stacked vias, HDI stacked vias, and the vias are going to be 40 microns off. So I have the 1 to 2, 2 to 3, 3 to 4. As they go down through the stack, they're all 40 microns off. And I'm starting off on the C4, I come up through the dies, and I'm ending out here on this one. This middle one is a tap. So I'm tapping into the middle of the chain, and that way if I test this and I see that the chain breaks, I can test between the tap and both sides to see if it broke twice or it broke once. So you can have multiple taps on a chain as well. What's interesting here, though, is if I go and look at my 3D view, and let's go ahead and tile this so I can see it, and let's go over and zoom in on here. The RDL1 is the blue layer and UBM is the red layer here. So I have one RDL connection, RDL1 connection, and two, the tap and the end here are going off on the UBM. So as I zoom in on that, the reason I did that and the reason the 3D view actually comes in handy here is if I look at this, when I'm bringing this connection in, I actually want to start on top of my via stack. So in here, I can kind of see my via stack and it's going down through. And if I brought this on the UBM layer, I wouldn't pick up this stack at all. So here I'm pulling that off on the top layer. And then the tap itself, it doesn't really matter. I could be on the top or the bottom for the tap. But at the last connection here, I definitely want to have a UBM connection because I have a via stack going down through. So here, I would have missed this stack if I would have routed it on RDL1 into the connection. And what you're seeing in red here are the die connections. So we can trace the via up through, and you can see how that is actually chaining through here, and we're picking up our silicon die connections. So sometimes we're testing things like mechanical, our bumps, balls, copper pillars. Sometimes we're testing features like this on the package side, what happens if we do this. And then sometimes you just do straight daisy chains on the package side, and they're actually checking features on the silicon side. So you might just chain this together on the package side just with RDL1 routes or something like that, and they're actually checking something on the silicon side. So it has many uses. Many customers use it for different things, but that is basically the gist of what test vehicles are and what the daisy chains or how they're used inside of the test vehicles. So you can, with XPD, you have the daisy chain creator. This can, like I said, it can manage your die package, your package PCB, or your die package PCB interfaces. So you can have 3 levels, and the package could be an interposer, so it could be die interposer package, but it handles 3 levels. It handles external connections above what you're working on and external connections below what you're working on. So the chains above and chains below. It has a graphical user interface for the creation. For the arranging, you can select chains across all the interfaces. You can easily select, color, and name the chains easily. It has a documentation feature where you can actually make documentation for the chain connections for whoever's doing your testing. And importing, it can read an ASCII file to read in your die or board connections, or you can read in your package connections. So these are just simple CSV files. It also has the ability to read in DXF intelligently. So if you've done your documentation for your chains and AutoCAD want to convert that over and read it into XPD, this will take the AutoCAD data and intelligently turn it into your die connections. So you can use XPD Daisy Chain Creator to do your verification. And we also have some verification tools. I have input. Now, I'm the creator of this, and I have input from many different customers. I'm in the field, so it's field developed and supported. But what that gives you is fast response time and custom functions. So, if you're using it and you're like, Kendall, I need this, I can go off and make things happen pretty quickly and turn around a new build very quickly, or implement custom functions that are needed. So it's evolving as new requests come in, and I have some open items I'm working on that I'll talk about. So this was done in phases. It just didn't start off as a big tool. The first phase was, had a customer, they had external connections. Hey, we have these external connections on our die. We want to be able to see them on our package. So it was just a simple, let's read those connections into a user layer so the designer could actually see the die connections. And it eliminated a lot of the mistakes from manual entry. The second phase of that was, hey, can we, now that we have these connections in here, can we highlight a whole chain? Well, that user layer is not part of the electrical model of the database, so it was just a user layer. So it created basically a function that goes off and looks at that user layer and looks at the endpoints of that draw segment and says this is connected to this pin and this pin. So from there, it can track a chain across both the physical nets in the package and across this user layer between 2 pins and come up with a connectivity model. So it basically works that way. It's using the user layer, but it has a connectivity model behind it. But once you have it selected, you can name the chain, or you can actually color the chain. We'll see in the demo. So here, the third phase was, now we've read these chains in intelligently, I want to make chains on my own. I have a customer came to me and said, we don't have someone doing our die, we do the die ourselves. So we have the ability to not only put in the package connections, but we have the ability to put in the FUB connections, the functional user block die connections. So that's third phase, is being able to put rows and columns in the design database and create these chains efficiently and effectively. The fourth phase was documentation. As you can see on the right up here, this is one line, but it actually represents different connections in the database. So as you see it, the user layer just goes point to point. So I can't tell what pins on here they're connected to, but the documentation layer splits that up and says, oh, the first one is connected to the last one. So it's readability. So now you can actually have documentation that goes along with your database, so someone that's testing this out in the lab, they can follow the chain across it. Not only does that, but it also supports multiple levels. So you can have the top layer die connections or the bottom layer board connections. So you can have board, package die, package board, so you can have multiple levels of activity. Phase 5 is what we're in. Some of the things I'm working on is where to start and stop the chains in the block, and I have a couple bugs and some grouping capabilities. But this is one you can see here. As you go through and you start, and someone wants to start and end at one section, it doesn't do that, but it's pretty easily manually to do it. So next slide, let's go into a demo. It's easier probably for me to show you how this works than it is to go through a bunch more slides to see how it works. I'm an AE, so it's easier for me to show you a demo than go through PowerPoint slides. So let's go to Package Utilities, Daisy Chain Creator, and let's keep this on top. And what I have here is I have a bunch of C4s, like I explained in the intro, with 2 dies on here. So the basis for this is you can create chains. The chains can have names. So if I list the design prefix names, I can see I have a red chain, a pink chain, and a green chain in here. And you're like, I don't know why you called them red, green, and pink. Well, I don't have the color by nets on. So if I have color by nets on, I can see the red, green, and pink. And then I have this oddball one right here called CA47. So if I look at that and I want to make it a color, I can open up the color wheel and I can make this like yellow. And in here, if I grab this and call it yellow, I can come to the arranging and say add prefix to selected. Now when I update my list, I have a yellow, pink, a red. So you can name these C1, C2, C3, whatever you want to name them. So there's 2 ways to do this. One is creating by scratch. So one of the last designs I worked on with a customer, we actually did the die in Xpedition, XPD, and we GDS'd out the die data as well as the package data. So we had full control of where the chains were on the die as well as the package. So with doing that, it's just a matter of going to creation, selecting 2 pins and saying connect those with a net. I want to connect the next 2 with a die connection, a FUB, connect the next 2 with a net, and you just keep it going on here, connecting them across as you want. And when you get to the end of your chain, you pick another pin that you want to go to, and you say, I want to connect those 2 with a net. Or I picked 2 pins in this case where I connected them together with a net. Now, you can see I called that green. So this definitely isn't green. So since I didn't change the name, this is green, that's green. So what I can do is I can select it, I can highlight it, it gets everything highlighted. I can call this my chain 1 and add prefix to selected. Now I've just renamed it. And if I want to open the color wheel and give it a color, I can absolutely go off and do that. But this is the basis for a chain. The other thing you can do in here is if I select across these, instead of, let me get in route mode so I know what I'm doing here. If I select across these, I can say, let's go ahead and make those a row. And you can have multiple rows, but basically it does all that manual chaining for me and just daisy chains down. So I can do rows or columns, or even if you wanted to do one row at a time. So I can grab this and say, let's make that one row, and it puts in one row for me. And then I just, I just need to go off and, pick a C4 that I want it to go to and connect those with the net, and do the other side and connect those with the net. So I've got those all connected up, going through here. Some of the validation of this is if I go to validation, I can say find one pin nets. And what that does is it looks in the design and it finds these two pins, which happen to be the ends of chains that didn't come out. So it goes off and looks for basically dead end chains. So the way it does it is it's looking at, I have a die connection here with the user layer. Then I have a daisy chain over here with a functional, or with a package connection, die connection, package connection. So it goes through that and says, look, I have this end pin that's not going anywhere. So I do have some validation in here, verification that says, hey, something's going on. These two didn't come out correctly. One of the other things that we started off is if you're not doing the die, someone may give you the die connections. So in here, I can say, read those FUBs from a file, and it reads them in and puts them into your design. So you don't have to manually create it. You can read it from a simple CSV file. You can also do that for nets. So if you have basically package connections that you've already done, you can read that net list in from the package, and it reads it into the design as well. So you can see in here that it's read those in. Now the interesting part about this is this is on a user layer, so that one is going all the way across. And if I look, there's another one underneath of this. Let me go to draw mode, it's easier. If I look, there's another one, there's three connections over top of each other. But graphically, you can kind of see it if you turn down your graphics setting a little bit, to see the OpenGL. But that's one of the reasons we have the documentation layer. So if I go in here and I'm looking at this and I say create the documentation layer, what it does is it goes in, looks at those connections, and basically makes another user layer with a bend in it. So if I actually printed this out and gave it to someone, they can really easily tell what's on the die versus what's on the package. So, this one, of course, is dead-ended, but I can see what's on the die, and here I have a chance of reading it. So it comes in here, jumps over, up, over, down, over, up, over, down, over, and then back out to the C4. And this one does the same over here on that side. So that's the documentation layer. The other thing, as I was showing you, you can go through and let's see here. If I go to arranging and I grab one of the pins on this and I say, let's highlight the entire chain. Let me close that and open it back up. That's a bug I found, but I need to fix it. So let's open it back up and say arranging, highlight entire chain. It goes off and it highlights the entire chain for me in here. Well, this is a multi-level tool as well. So we can actually have connections on the BGA side. So if we look at this side and I connect this one to this one and I say connect those with a FUB, it adds a FUB in, but it adds it in on the board side. and then I can come in here and say this one and this one, connect those with the FUB. It adds it on the board side. Now, if you click on any of these pins and say highlight, it goes through and then highlights the entire, all three of those chains. If you go to documentation and create the documentation layer for this, what it actually does is the top connections or the die connections are in red, and the board connections where it's shorted out on the board is in green. So it can handle multiple tiers of basically of the connectivity. So you can have subchains and that are part of a larger chain that goes die or board, package, die, board, or package, board. You know what I mean. It goes through all those levels, and this keeps track of those levels for you. So let's turn the documentation off and get back to just to the FUBs, and we can see that inside of there. We had the verification where we could find the 1-pin nets, and then the miscellaneous is I have it this as I'm writing this, a miscellaneous is what I'm writing at this time. So people have this in production, but I'm still adding to the form. What this does is if you read in a bunch of connections from an external source, you could read in 100 chains. Well, that would be a daunting task to go off and find each chain. So what this does is find chains is it walks through your entire design and finds the chains and names them for you sequentially. So instead of spending the afternoon doing this manually, walking through and finding them all, you can click on find chains, go to lunch, come back, and it'll be done. So that's pretty powerful as well inside of there. And then on the importing, we also have this importer for DXF. So we have a number of customers that have used AutoCAD to document their chains, and their chains are in a DXF layer. We can actually read in that DXF layer and make it intelligent. So basically, I can read it in and turn it into the FUBs layer in the design to read in that external source. So we can read it in from a file, or we can read it in from a DXF. Now DXF's dumb data, so some of this stuff in here, you don't have to run through all the the different things in here, but like this join target segments is if the DXF is bent, and they give it to me, and the bends don't connect as one polyline, this goes and connects the bends as one polyline, so I can find the start and finish, because that's what I need for doing the FUBs in here, is I need the start pin and the finish pin. And if it's bent like we have on the DC top, this has to be one polyline like this, so I can find the start of it and the finish of it, so I know where I need to put the connection in for the die connection. So there's a lot to this as you go through and use it. You may find more things that you say, hey, I'd like to have this. That's fine. We're open for taking in more suggestions on how people want to do these things. But this is a pretty good start for managing your daisy chains inside of your test vehicle. Thank you. I hope you learned something from this about daisy chains and test vehicle creation.